Here we have a problem from the UNC 2014 math contest, and it gives us this little pin pad and a couple of rules and asks us to find the number of 3-letter combinations and the number of 4-letter combinations. The rules are that we cannot use any 2 keys in a row, meaning we have to move keys, and we're only allowed to move left, right, and diagonal from the key that we're currently on. And we can start from any key we want. So if we start with A, we can only move to B, D, or E as our next keys. And we also can't press A twice in a row. So the key A, E, C is completely fine. The key A, E is not fine because we'll have pressed 2 keys in a row. And the key A, C, F is not okay because there's no way for us to move from A to C. So let's jump into the first part of this problem that asks us to find the 3-letter codes. So let's start with our letter A. So if we choose A, we have 3 combinations past that, B, D, and E. And then if we choose to jump to B, we have 5 different combinations for our last letter. So A, B gives us 5 numbers. If we go A, E, then we have 8 numbers as our last letter. And if we go A, D, we have 5 numbers as well. So that means adding all of these up, if we choose A as our first number, we have 18 different possibilities after we choose A as our first letter. Okay, but that goes for all of the corner letters because there are 4 of them. So that means that we have C also giving us 18 possibilities, G also giving us 18 possibilities, and I giving us 18 possibilities. And adding all those up, we find that we get 72 different possibilities from starting on the corners alone. Now let's check if we start in the middle. So we'll take B as our example here. If we start with B, that means we have 5 different combinations after B. So if we go BA, we have, let's see, B and then A, we have 3 different combinations to end that off. Same with BC because BC is also in the corner. So we have 3 different combinations there. If we go D or F, we have 5 combinations from those. And then if we go to E, we have 8 combinations to finish our 3 combination lock. Adding all of these up, we have 2 copies of 3, 2 copies of 5, and a copy of 8. That will give us 24 different combinations if we start with the letter B. But again, we have 4 of those because B, D, F, and H are all in the middle on the edges. So B gives us 24, D gives us 24, F gives us 24, and H gives us 24. And adding all of those up, we get 96 different combinations if we start on the middle edges. So now we're only left with when we start with E. So let's go ahead and clean this up a little bit. I'll move these up maybe to the top, and then we'll finish off this first part of our problem. Okay, now let's go over when we start with E. So if we start with E, we're going to have to move to either a corner or a side, and those split up 2 different ways. Those split up 4 and 4. But then if we go to a corner, we know that our last number is going to be 3 different possibilities. So we can multiply those. And if we go to a side, we know that our last number is 5 different possibilities. So this gives us 32 different possibilities for when we start with E. So the total number of 3-letter codes is equal to 32 plus 72 plus 96. And that's equal to 200. So this is our answer to letter A, the number of 3-digit codes.